Welcome back, Honors 317 Essentials of Life, Air and Water. In this video, we're going to focus on watersheds and how we organize or count or enumerate how big a watershed or the streams and rivers within it might be. So with that said, I'll move into the slides. So first of all, it's important to know that many boundaries that exist in the United States and around the world follow water courses as well as these topographical boundaries that might include also ridge tops or high points. So here is an example of Rowan County, Kentucky, and like many counties, this border is a ridge line. And here we also have a river itself actually dividing it. So these ridge lines or divide lines actually separate the county's watershed from the other counties, which is actually kind of good because this county has the ability to completely influence all the things happening in its county with respect to the main waterway in the county. So this is the North Fork of Triplet Creek, that's Triplet Creek. And then over here is Carter County, Kentucky, which has the Tigris Creek watershed. And up here is Lewis and Fleming County, Kentucky, and this I believe is Fleming County over here, and they have the Fox Creek watershed or Fox Valley watershed. So those particular watersheds are separated, and then here we have the Licking River. So many of our boundaries in Kentucky exist this way. If you're heading south out of Madison County, where EKU is at, when you get to Rockcastle River, you enter, or Rockcastle, Kentucky, you enter a new county just south of Berea there, and it's on a ridge line. You continue to head further south into Laurel County, and it uses a river, the Rockcastle River, to separate. To the north of EKU, Fayette County, it's separated from Madison County by the Kentucky River. So it's just helpful to know about our county boundaries and their relationship with water. The Kentucky River itself, which it's highlighted here in this outline of blue. This is the Kentucky River Basin for Kentucky, and Louisville is in this general area over here. Cincinnati is up here. EKU is right here, and Virginia is right here. So the Kentucky River, which starts on this outer edge of Pine Mountain, the northern edge of Pine Mountain, flows a good ways to the Ohio River. So it's a very large river basin, and it's part of a larger basin, which is part of the Ohio River Basin. So as we move on, I wanted to show a few slides here. I'll get to it here in a second, I guess, on how topographical maps are read. But as we speak to these watersheds right now, we're going to speak to the Mississippi River Basin just in terms of the size of it, which it includes parts of Canada, and includes everything as far as northeast as upstate New York. Some say that the Ohio River Basin should be the name of this whole watershed because in terms of the volume of water produced by the Ohio River watershed, which includes the Tennessee River, this whole area produces more water into the Mississippi than the upper Mississippi and the Missouri basins do. But these obviously occupy far more area, and Missouri has the most area, and we don't call it that. So that's just something about the naming. Some folks say that the Ohio should be it, but I won't go much further than that. So the Ohio River Basin is actually comprised of, we have many rivers. We can start all the way up here in upstate New York with the Monongahela and Allegheny rivers. We have the Tennessee River system, the Cumberland River. They all flow into the Ohio River. We have the Kentucky River, right, actually, and we have the Licking River as well. So the Kentucky River goes further on down, by the way. But anyways, this is all the Ohio River Basin. The Ohio River Basin, or Ohio River Watershed, is part of the larger Mississippi River Basin or watershed. These terms, basins and watersheds, are used interchangeably. Basins generally are viewed as being larger, but they're still watersheds. And in the European Union, or in British English, they refer to basins and watersheds as catchments. That's the word that they use. All right, so I'm just going to skip through some. Now, when we're counting or enumerating the size of a watershed or a waterway, there's a couple different ways to do it. Everything from HUC codes, which are HUC codes, which are classification systems, to the Strahler method. The Strahler method is the most common one, the Strahler. And how do we do the Strahler method? Well, the Strahler method, it takes these small streams that you might think may look like a ditch. Those are called first order streams. And these first order streams join together to become second order streams. And second order streams have to join another second order stream to become a third order stream. These first order streams get a lot of attention sometimes in legal proceedings because the Clean Water Act and whether or not it actually should protect them or not. And we know that what happens in these first order streams can have a huge impact on what happens in the second and third and fourth order rivers and larger water bodies. But there are some folks that would do their pollution. It's easier to pollute these, and it's also harder to protect something that's so small. So where does the government draw its lines on what can be protected or not? So first order streams are sometimes called headwater streams, get a lot of attention in the legal proceedings and in the news for whether or not they should be protected or not. And in order to do the enumeration using the Strahler method, it's important for us to know that a first and a first have to come together to become a second, and a second and a second have to come together to become a third. So in this little example I have here where I've got these X's, this X and this X would reflect a first and a first coming together to form a 2. And this is an X, that would be a 1. So the 1 and the 2 would come together and it stays a 2. This would stay a 2. Alright, so first and first becomes a 2 and a 1, it stays a 2. And that's a 1, so it's still a 2 at that point. Hopefully that makes sense. So a third and a first, it's still a 3. A 3 and a 2, it's still a 3. But if there was a 3 and a 3, then it becomes a 4. Alright, so that was the little example we just ran through. You've got an example on that online quiz. So for the watersheds in the world, the Ohio River itself, the Ohio River at this point right here is an 8. The Mississippi at that point may be a 7 or an 8. Ultimately, the Mississippi ends up where it comes out at as a 10, right here at the Gulf of Mexico zone of hypoxia there. It's a 10. So the Mississippi is a 10. So you can think of one Ohio River meets another Ohio River makes it a 9. Another Ohio River meets another Ohio River, that makes it a 9. And then those come together and that's the size of the Mississippi, a 10. The Amazon is the world's largest at 12. Larger than the Nile, larger than the Danube. It's a 12. So how do we get to a 12? You have to think of it. There's one Mississippi River meets another Mississippi River to become an 11. And over here, one Mississippi River meets another Mississippi River to become an 11. And then those two become an 11 and 11 joined to become a 12. So the Amazon is substantially larger in terms of the amount of not just the ordering of their streams and rivers, but also in volume. It's a very large river. And that's why it also has like dolphins and its own ecosystem and everything else. So you've got these review slides that are available on your notes. So hopefully this was helpful. If you have any questions in doing your homework or not understanding something, or you need some more time, or there's any issues that come up, please do not hesitate to contact me or contact Dr. Brown. I'm jason.marion@eku.edu, and you got Doc Brown, gary.brown@eku.edu. So again, if you have any issues in trying to do these assignments or accessing the online videos or accessing any of the materials, please let us know. And I hope everything else is going well for you, and I hope the rest of your classes are going well. So thank you and take care.